Hello students, I am Assistant Professor Priyanka Kashir from Department of Chemistry, SSGM College, Kopargaon. Today, I will discuss with you the analytical course CCTB at Analytical Method Development and Extraction Technique. In that course, third chapter I will taken in that video lecture, solid phase extraction. After going through this unit, the student will able to the important variables in performing SPE means solid phase extraction. Select the most appropriate sorbent for SPE. Methods for solid phase extraction operations, factors affecting on solid phase extraction and the practical applications of solid phase extraction. Introduction. Solid phase extraction SPE is a popular sample preparation method used for isolation, enrichment and cleanup for components of interest from aqueous samples. Solid phase extraction normally involves bringing an aqueous sample into contact with a solid phase or sorbent whereby the normal compound is selectively absorbed onto the surface of the solid phase prior to elution. The solid phase sorbent is usually packed into small tubes or cartridge. Recently, many developments in solid phase extraction technology have taken place including new formats. Example, disc, pipettes, tips, 96 well plates, new sorbents, example silica or polymer phase media and mixed mode media, and the development of automated and online systems. Whichever design is used, the sample containing solvent is forced by pressure or vacuum through the sorbent. By careful selection of the sorbent, the organic compound should be retained by the sorbent in preference to other extraneous material present in the sample. This extraneous material can be washed from the sorbent by the passing of an appropriate solvent. Subsequently, the compound of interest can be eluted from the sorbent using a suitable solvent. This solvent is then collected for analysis. Further sample cleanup or pre-concentration can be carried out if desired. Types of SPE media sorbent. Generally, solid phase extraction sorbents can be divided into three classes, that is normal phase, reverse phase and ion exchange. The most common sorbent are based on a silica particles, irregular shaped particles with a particle diameter between 30 and 60 micrometer, to which functional group are bonded to surface silanol groups to alter their retentive properties. The bonding of the functional group is not always complete and so unreacted silanol group remains. These unreacted sites are polar acidic sites and can make the interaction with compounds more complex. To reduce the occurrence of these polar sites, some solid phase extraction SPE media are end capped. In this nature of the functional group that determines the classification of the sorbent. In addition to silica, some other common sorbents are based on a fluorocide, alumina and macro reticular polymers. Normal phase sorbents are polar functional group. Example, cyano, amino and diol. Also included in this category is a unmodified silica. The polar nature of these sorbents means that it is more likely that polar compounds, example phenol, will be retained. In contrast, reverse phase sorbent have non-polar functional group, example octadyl, octyl and methyl, and conversely are more likely to retain non-polar compounds, example polycyclic aromatic hydrocarbons. Ion exchange sorbents have either cationic or anionic functional group, and when in the ionized form attract compounds on the opposite charge. A cation exchange phase such as benzene sulfonic acid will extract a compound with a positive charge. Example phenoxy acid herbicides and vice versa. A summary of commercially available silica bonded sorbents is given. SPE formats and apparatus. There is a diagram of solid phase extraction using a cartridge and a single side arm mask flask apparatus. Then SPE formats vacuum manifold for a solid phase extraction of a multiple cartridge. Then it is a solid phase extraction using an empore disc and a single side arm flask apparatus. The design of the SPE device can vary, with each design having its own advantages related to the number of samples to be processed and the nature of the sample and its volume. The most common arrangement is the syringe barrel or cartridge. The cartridge itself is usually made up of polypropylene with a wide entrance through which the sample is introduced and a narrow exit. The appropriate sorbent material, ranging in mass from 50 mg to 10 gram, is positioned between two frets at the base, means exit, of the cartridge, which act to both retain the sorbent material and to filter out particulate matter. Typically, the fritz is made from polyethylene with a 20 micrometer pore size. Solvent flow through a single cartridge is typically done using a side arm flask apparatus where multiple cartridges can be simultaneously proceed from 8 to 30 cartridge using a commercially available vacuum manifold. In both cases, a vacuum pump is required to affect the movement of solvent sample through the sorbent. The most distinctly different approaches to solid phase extraction SPE is the use of disc. Not unlike a common filter paper, the SPE disc format is the referred to by its trade name of empore disc. The 5 to 10 micrometer sorbent particles are intertwined with fine threads of PTFE, which results in a disc approximately 0.5 mm thick and a diameter in the range 47 to 70 mm. Empore discs are placed in a typical solvent filtration system and a vacuum applied to force the solvent containing the sample through the minimize dilution effect that can occur. It is necessary to introduce a test tube into a filter flask to collect the final extract. Manifolds are commercially available for manual sample extraction using the empore disc. Then the next point is the method of solid phase extraction operations. There are 5 stages of solid phase operation: wetting the sorbent, conditioning of the sorbent, loading of the aqueous sample, rinsing or washing the sorbent to elute extraneous material, and the elution of the compound of interest. There are 5 stages are given in the diagram. First one is wetting or sorbent. Second is conditioning of sorbent. Then loading of sample. Middle diagram is the loading of sample. Then interface elution. Then analyte elution. Fifth one is analyte elution. Wetting the sorbent allows the bonded alkyl chain, which are twisted and collapsed on the surface of silica, to be solvated so that they spread open to from a bristle. This ensures good contact between the compound and the sorbent is the adsorption stages. It is also important that the sorbent remains wet in the following 2 stages or poor recoveries can result. This is followed by conditioning of the sorbent, in which solvent or a buffer similar in the composition to the aqueous sample that is to be extracted in a pool through the sorbent. For aqueous sample, this might be deionized or distilled water. This is followed by sample loading, where the sample is forced through the sorbent material by suction, a vacuum manifold or plunger. By careful choice of sorbent, it is anticipated that the compound of interest will be retained by the sorbent in preference of extraneous material and other related compounds of the interest that may be present in the sample. Obviously, this ideal situation does not always occur, and compounds the similar structures will undoubtedly also be retained. This process is followed by washing with a suitable solvent that allows unwanted extraneous material to be removed without influencing the elution of the compound of interest. The stage is obviously the key to the whole process and is depending upon the compound of interest and its interaction with sorbent material and the choice of solvent to be used. Finally, the compound of interest is evaluated from the sorbent using the minimum amount of solvent to affect quantitative release. Be careful control of the amount of solvent is used in the elution stages and the sample volume initially introduced onto the sorbent. A pre-concentration of the compound of interest can be affected. Successful SPE obviously requires careful consideration of the nature of the SPE sorbent, the solvent system to be used, and their influence on the compound of interest. In addition, it may be that it is not single compound that you are seeking to pre-concentrate, but in range of compounds. If they have similar chemical structure, then the mood method can be successfully developed to extract these multiple compounds. While this method development may seem to the laborious and extremely time consuming, it should be remembered that multiple vacuum manifold and commercially available as are robotic system that can carry out the entire solid phase extraction process. Once developed, the SPE method can then use to processing large quantities of a sample with a good precision. Then next point is the solvent selection. The choice of solvent selection directly influence the retention of the compound on the sorbent and its subsequent elution whereas the solvent polarity determines the solvent strength. The solvent strength for a normal phase and reverse phase solvents are shown in below. Obviously, this is the ideal. In some situation, it may be that no individual solvent will perform its function adequately, and so it is necessary to resort to mixed solvent system. It should also be noted that for a normal phase solvent, but solvent polarity and solvent strength are coincident, whereas this is not the case for a reverse phase sorbent. In a practice, however, the solvent normally used for the reverse phase sorbent are restricted to water, methanol, isopropyl alcohol, and acetonitrile. For ion exchange sorbent, solvent strength is not the main effect. Then the next point is factors affecting SPE. While the choice of SPE sorbent is highly dependent upon the compound of interest and the sorbent system to be used, certain other parameters can influence the effectiveness of the SPE methodology. Obviously, the number of active sites available on the sorbent cannot be exceeded by the number of molecules of compound, or otherwise breakthrough will occur. Therefore, it is important to assess the capacity of the SPE cartridge or disc for its intended application. In addition, the flow rate of the sample through the sorbent is important. Too fast a flow and this will allow minimum time for compound sorbent interaction. This must be carefully balanced against the need to pass the entire sample through the cartridge or disc. It is normal, therefore, for a solid phase extraction cartridge to operate with a flow rate of 3 to 10 ml per minute, whereas 10 to 100 ml per minute is typical for the disc format. Once the compound of interest has been adsorbed by the sorbent, it may be necessary to wash the sorbent of extraneous matrix components prior to the elution of the compound. The choice of solvent is critical in this stage, as has been discussed previously. For the elution stage, it is important to consider the volume of solvent to be used. For the quantitative analysis by, for example, HPLC or GC2 factors are important. Pre-concentration of the compound of interest from a relatively large volume of a sample to a small exact volume, and cleanup of the sample matrix to produce a particle free and chromatographically clean extract. All of these factors require some method development, either using a trial and error approach or by consultation with existing literature. It is probable that both are required in a practice. Thank you for watching the video. Have a nice day.